Next question. So we have the integral of 2 divided by cosine theta minus 1 d theta. This is the same as dx, but instead of having our argument as x, it's theta, so d theta. First, let's bring the 2 out of the integral to the outside. We want to remove trig expressions in the denominator, and the easiest way to do that in this case is going to be to multiply by the conjugate, which is cosine of theta plus 1 over cosine theta plus 1. This is just something that you need to remember when you see problems of this archetype. So now, when we multiply, we'll have cosine theta plus 1 in the numerator. So if you just did 1 times cosine theta plus 1, divided by cosine squared theta minus 1 in the denominator, when we multiply cosine theta minus 1 and cosine theta plus 1. Now notice we can use the Pythagorean identity to convert this expression into a different trig function. So let's write out sine squared theta plus cosine squared theta equals 1. So if we want it to be minus 1, let's move the 1 to this side. Minus 1 equals, and let's move the sign to the other side, making it negative. So it equals negative sine squared theta. All we did was add negative sine squared theta to this side and this side. So this becomes 2 times the integral of cosine theta plus 1 divided by negative sine squared theta d theta. We can break this into two different functions. So let's do that. This will become 2 times the integral of cosine theta over negative sine squared theta d theta plus 2 times the integral of 1 over negative sine squared theta d theta. Now, for this integral, let's bring the negative 1 outside, making this negative 2 times cosine theta sine squared theta d theta. But for this one, let's leave the negative in, because this will become negative cosecant squared theta d theta. I left the negative with cosecant squared theta because if you remember, the integral of negative cosecant squared theta is cotan theta. That's just a trig identity that you should remember. A trick I use to remember the trig identities is I write out secant, secant, tan, cosecant, cosecant, cotan, but the middle cosecant is negative. The integral of negative cosecant squared theta, and that's when we multiply these two, which are next to each other, is equal to cotan theta. And similarly, the integral of negative cosecant theta times cotan theta is equal to cosecant theta. So the integral of these two multiplied to each other is this, and then the integral of these two multiplied to each other is this. And the same goes for the top with secant and tan. The integral of secant times secant, which is secant squared, is equal to tan theta, and the integral of secant theta tan theta is equal to secant theta. So just remember, when you multiply two that are next to each other, the integral of them, the integral of that product is equal to the one remaining in the row. Anyway, let's get back. So to integrate this, we can just do a simple u substitution by setting u equal to sine theta, meaning du is cosine theta. So when we bring this down, it becomes negative 2 times the integral of du over u squared, which is equal to negative 2 times u to the negative 2 du. We can easily integrate this, and it becomes u to the negative 1 over negative 1 plus c, which is just 2 times u to the negative 1 plus c, which is 2 to the sine theta negative 1 plus c. And remember that sine to the negative 1 is just cosecant. So this becomes 2 cosecant theta plus c. When we bring everything together, our final answer is 2 cosecant theta plus 2 cotan theta plus c.